Hi everyone, my name is Sabillon, and I'm going to make a demonstration about my project implementing the approved classification dataset using the EfficientNet model, that is a CNN model implemented for images classifications. So EfficientNet is one of the most modern data models after ResNet or Model VNet for image classifications. This was made by Google in 2019. And well, what about the dataset? Our dataset is about fruits and vegetables and some nuts. It was released on 2020, but actually they always update the dataset, so it has been updated in this year in June of 2025. The dataset consists around. Actually, this is not updated. So the dataset consists around 100,000 images, and 80,000 images are for training, and 20,000 images are for testing. Sorry. Also, in this dataset we have 26 classes, so we can identify 206 different classes of vegetables, fruits, and nuts. So let's see the code after the demonstration. So here we import and we use TensorFlows and Keras for importing the EfficientNet model and training it and prepare it for the environment. Also, we are working with GPUs in the color environment. So first we load the data from our dataset is in this folder called fruits, and in this folder. So we upload it, and of course we need to resize the images to this size because it's the required one for EfficientNet. 224 by 224. We image size. Also, we push the batch size in 16 because the RAM dies when we have a bigger batch because there is no enough memory. Also, we resized the testing and the training both. Also, we add shuffle false because we need it for making sure that we are going to have the right metrics. As we explained, we have 206 classes. We got the name of all the classes. As you can see, are many fruits and vegetables. Then we show the images, a quick look for the images. And then we start to convert the dataset. For performance, we do data augmentation for make it more accurate. And then, of course, we implement the model because we have it here in the files, EfficientNet, and then we start to create it and build it. Here we build all the layers needed for the model, like the pooling layer, the input extraction, everything. Then we can see a summary about the layers. So you can see input layer, rescaling, normalization, etc. There's a lot of them. Let's make it quick. Here we are training the model. So we have the epochs. We defined 5 epochs with the trained data set. It means the 80,000 images. So as we can see in the accuracy and loss, for each epoch the accuracy is increasing and the loss is decreasing. Finally, we got 98% of accuracy in our final epoch in the training. So we have these metrics about the accuracy score, F1 score, report score, classification score, confusion matrix. So as we can see, we got this score in the training. and accuracy is 96, almost 97%, it means almost every class could be identified and well trained, so that the model can separate and classify them separately. The same F1 score is high, so it means that we have a good relation between the false positives and false negatives. Our model is working well. Also here we can see the report about each class and their scores. And yeah, here also the support is the samples that we provided in the model in the dataset. Here's the confusion matrix. The confusion matrix is for understanding which classes has more confusion between each other. Maybe because they have the same color or the same shape or everything. Then we have this part, the training and validation accuracy. As we can see in the curves, our training accuracy is around 96, almost 97, 97, but the validation accuracy was higher. Also, when it started to training, it was very low, as we saw in the epochs before. It started very low, then it incremented a lot. Here you can see, like at the start, it was 0. The first epoch was not so good, then it was getting better and better and better. And with the validation one, it was very in the beginning because we have trained it before. So we got an accuracy of 96 and a very low loss. So all the classes can be identified easily since the beginning, even if the model have never seen them before. So also the loss, we can see the loss here. At the beginning it was a lot in the training, then it was decreasing. Now we have the demonstration about prediction of the images. So here's the funny part. We finished, we identified how they should look, and here we start with the prediction. So which images are we testing? I uploaded many datasets, small datasets of images here, like making reference to some fruits. Here we have apples, manzanas is apple in Spanish. We have apples, we have pineapples, we have bananas, mangoes. Also we have a sample of pomelo. So we uploaded the image, we read it, and then we test it. We make the prediction. So as we can see, here's the image and identified. The prediction here, prediction is predicted level of the image array. So we identified as a banana. In the next sample also, we have banana 200. It also identified as a banana with a high confidence on it. Then also we have this sample. It's a wrong sample, as it was required in the assignment. We have mango, and the system says it's a pomelo instead of mango. Of course, it cannot be so accurate because the colors are similar, the shapes. We have another sample, another wrong sample with another mango, and it says it's a pea red. It's not a mango, it's a pea red. We know it's a mango because we looked for a mango. At the same time, we have another mango because we couldn't find a good sample with mango, and it also says it's a pomelo. Then we have a real pomelo. So here's the pomelo, and the system identifies it's a pomelo. We have more samples with apples. The apples, this is a wrong sample. In this example, the apple is not identified good because it says it's a pea red instead of an apple. Of course, we have more apple samples, and here with this picture, manzana verde 200, we have an apple. It identified correctly that it was an apple. The same here, another apple. We have another image of an apple that we uploaded from Google, and it's an apple effectively. Also, we have another one with apples. This is a red apple, and it also identifies it's a red apple. The next sample is this one with the mango, pomelo. Is a wrong, and then we have pineapples. Okay, with the pineapples we got these results. We identified that the first image was a pineapple, so it says the prediction is a pineapple. We have another one, different background, and also it says the prediction is a pineapple. Then we have got another one with pineapples, and we got a wrong result. It says it's a cherry moya, and a cherry moya looks so different. Here we have the cherry moyas, so it's so different to the pineapple. But maybe it was confused because there are some similar shapes. Maybe the colors between the the structure of the pineapple, the green parts may confuse the model. So this is the demonstration. As we could see, we have wrong examples, good samples, and we have the resource questions. So the resource questions are the following. How accurately can be a deep convolutional neural network as efficient at classifying different fruit types? As we saw, it's very accurate. Most part of the time it's going to give accurate results. How does the image resolution affect the performance? Okay, about the performance, I think it's not so difficult, so important because all the images had the same resolution of 224, all of them, and despite that, not all of them got good results because they had similar lighting and background conditions. So, can a lightweight deep learning model be effectively deployed in resource-constrained environments like smartphones to assist non-experts classifying fruit in real time? Of course, if we connect this model and this code to an API that is consumed by an app for smartphones, we could easily identify and classify fruits in real time for people that they don't know about the fruits or they have never interacted with them because the fruits are from another region, etc. Which evaluation metric best reflect the model reliability in this specific task between diverse fruits? Or, in my opinion, the accuracy and F1 score, because those ones are the ones that was also measured in the training and the testing, and the F1 score makes reference about the false positive and false negatives, and also the accuracy makes reference about how accurate was the model identifying each class. So those sort of visual features like skin texture, color, hue, blemishes play a more significant role in fruit classification. In the study that we made and we tried on all the process, we identified that the color is an important, very important feature that plays a significant role in fruit classification. As we see, for example, with the apple, we have a red apple with some yellow parts, and it couldn't identify it was an apple because it has a little bit yellow, a little bit red, so it identified it was another fruit. It said that it was a pear red. So these are the results obtained for the presentation. Also, we made some metrics and graphs about the results.